I would take a little bit cooler temperature to have a solid temperature like this. It'll be a much better, more representative sample. Hot is great, but quality is a little bit, it's a balance between hot and quality.
Understood. So Sean, on the quad view, folks can see that green bar of the device GUI. What's that showing us?
So when I hit the button for sample, which I'm going to move it off so that I don't hit it again, there's a routine that the electronics go through. It'll open the valve for 30 seconds to allow the vent fluid to start entering the sampler, and then it'll stay that way for about 1.5 to 2 minutes, and then it'll go through a closing routine to close the valve and seal the vent fluid in the isobaric gas tight. And at the end of that, you'll see me, well, actually you won't see it because it's on a different panel, but what I'll do is I'll give another close command just to ensure that the sample is actually closed inside the IGT. And if you watch the right to the right of the word sample, there's a 0 MA, that's 0 milliamps. That's the motor feedback. So now that you can see the motor is turning, so it's drawing some current. And you should see that peg out at 800 milliamps. That's letting us know that the valve, the stem has seated in the valve and the IGT is closed. And that's when I'll give it another close signal just to be sure. We got such a nice sample, I'd hate to not make sure it's closed and bring it up to the surface and have seawater.
That's cool, thank you.
You can see that it's milliamps are climbing. Now I'm going to give that another tap, which you can't see. See, now that's at 820 milliamps. So I know that it is closed. And I will abort and I will put it to sleep. You can go to bed now. Close file. All right, great. Excellent sample. You can stow that and grab the other one, please.
Come wide, please.
Looks like max temperature of 297 degrees, but I'll confirm that when I go through the text file later.
I'm all the way right back.
Okay. Communications have been absolutely rock steady. For those that may be interested in listening to this on shore.
So who's winning the temperature sweepstake at the moment?
So far, whoever is closest without going over to 298.
What did you have, Nicole? 303?
304.
Oh.
Very specific. Oh, we all did 1 degree.
Yeah.
There was one person that wanted to do fractional degrees, and we decided that was not.
Bubble isn't terribly much help right now. Nice. One go.
All right, this is my favorite IGT, so let's see if we can beat the temperature record here.
Sean, what did you have as a guess?
I didn't have one. If I were to guess, I would have guessed 300.
Yep.
That would have been my guess.
You wouldn't be allowed to
How
be in this competition, I think.
Yeah, that's
disqualified.
Well, I don't have any insider knowledge that you don't.
you have a conflict of interest. You built the temperature probe.
That's true.
And he's also choosing which orifice we sample.
That is also true. So
Yeah,
I should be disqualified. I tend to agree with that.
So just for those of you watching on Nautilus Live, all of these temperatures you can hear us discussing are in degrees Celsius.
Zoom in, please.
Okay.
That's good.
You know if you want me to center up more on the hole.
Those of you watching on the Nautilus Live quad view, you can see those temperature measurements in the
Nope.
bottom
Sorry.
left.
There we go. I was on the wrong gas type.
The non-favorite.
Yeah. Now I'm on my favorite. So 297. Come on. Give me. Oh, 298.
Oh,
That was quick.
It's a really stable
Yeah.
position.
Yeah, this is great. All right, you're stable and set, Josh?
I am locked.
All right,
Yep.
locked and loaded. I'm going to press sample. And it's opening. Yep. I can see little flashes of silver as the coupling goes by, the motor turning between those two elongated silver standoffs between the coming out of the plastic towards the valve. It's letting me know that the valve is actually turning. I do get motor feedback from the current, but it's also nice to have a visual indication that something's actually happening. Max T so far on this one's 298. But again, I'll have to confirm that when I go back through the text code. IGT8 hardly ever lets me down. I will not say never.
Now that you say that.
No, hardly ever is okay. That still gives some wiggle room, but it's been a good gas type.
do you know how many times
Do you
each
want
of
an
these has
SD
been
on
used?
Argus?
Do you have a record?
We would have to add up all our cruises from about 2000 till now. Several cruises per year, 40 or 50 gas tights per cruise. It's
Oh, a lot.
it's significant.
Do you have to replace parts on them, or how often if you do?
They do wear out. The valve seats wear out. The snorkels certainly get bent and broken. The thermocouples we consider a consumable item because they do break and they flood, and I have to rebuild them. The cables get nicked and tugged and pulled on. The ICL paddle coils that we talked through get nicked and damaged and flooded. You know, working at these depths we take for granted, but there's a lot of considerations that need to go into it, and many of these things they just get ruined. They get broken. You know, no matter how careful people are, it's just the way it goes. There's no way around it.
Sean, out of curiosity, have we hit 300 yet?
We have not. We are still at 298 degrees.
It's kind of cool. It matches our max temp, 298 on our probe, so that's
Yeah.
good to know those correlate.
Yeah.
All right, we reached Mac current draw, but I'm going to just give it another little close command just to ensure this really nice sample is trapped inside there.
It's poetic.
Trapped inside.
Dark poetry.
Yeah, a poet is something I'm not known for being. All right,
Maybe just
put it
didn't
to
know
sleep. Close file. You can go ahead and stow that.
Okay.
Thank you. Great samples.
All right, zooming out.
Yep.
That was good timing. We're just coming up to the watch change. I just wanted to ask quickly, are any of you guys noticing any mic feedback on your audio?
Oops, sorry.
I don't hear
Mine's been
anything.
good.
No, audio in the room is good.
If there's feedback somewhere, just make sure you only have one instance of the Nautilus Live open, I guess. Would be one thing.
Oh, you mean advice for people watching?
Yeah, if it's coming from people watching.
Is that
Nice.
in the corner? Yeah, I think that's it.
Looks like it, yeah.
Yeah.
Nicole, do we want the sat up there again for future temperature reads? Sure. We are now moving on to super readings, so I think you could put back probably the, we'll need to see the whirly wheel eventually, bubble cam.
Oh, yeah, I'll just put a bubble.
Yep.
So yeah, we're into the wand now?
Yeah.
The same location? Is that right?
That's correct. We're setting up for Eric's work.
Okay.
Yeah,
I'll let
except
him
we
take
can't
over.
stick it into 300-degree water.
Right.
So maybe somewhere more diffuse up top of it.
Oh, so we're going to move the
It
vehicle?
says not to move if you can help it, but we're gonna.
I mean, if we melt the inlet one,
But-
we're not sampling anything.
But here's the question: should we do a temperature probe with ours
Yeah.
of like above it, so
That's
you
what
know
I'm
what the
thinking,
height
yeah.
is? Yeah.
I'm thinking like the temperature, the ROV temperature probe. Look for something that around like 100 degrees.
Okay.
That way we know it won't melt.
Right, because 120 is our max, right?
Yeah.
It's so hard working on these slopes. Get the right angle you want without getting the arm into the bumper bar. Yeah, let's zoom in, please.
Video, go ahead and zoom.
Yeah, we
Okay.
can zoom. Okay, that's good. Just gotta go.
So the instructions do say 1/2 meter to 2 meters above the vent.
Okay.
Yep.
Oh.
Thank you. Let's
Because I think
let's tilt up a bit.
it has to be less than 50 degrees or 60.
Zoom out a bit.
Yeah. Let's try. Where's going to be a good spot for the wand?
That doesn't look like it's getting too hot, so
No, so we can try to go a bit lower and start low and then kind of move up.
yeah. 50.
What's your? Oh,
is,
sorry.
is that in the vent hole? I can't
It's
tell.
not pointed down. I'm kind of just putting it in the flow.
Uh-huh.
It's because the IGT I kind of put like down, like in the hole down here.
Mm-hmm.
But this one I'm up above, definitely above where I was sampling.
Looks like about 70 degrees around that area. I think that'd be okay.
Yeah, I think as long as you don't put it like right down in the hole, then it's going to be. Well, let's see where this is still climbing.
Let's leave it there for a little minute.
Yeah.
What's your temperature range, Eric, for this?
You don't want to go too close to 120, so sub 120, but I think we're aiming for like a whole range of temperatures, like probably from 50 up.
Hey. Yeah, I mean, I could raise it a wee bit and see what we drop to. That's 115 there, 115.
Yeah, let's raise it like an inch or two.
Yeah. Yeah, I like moved it like an inch and we dropped, continuing to drop temperature.
73. Let's see what it gets when it's stable.
Wow, that's amazing. That's like 1 inch and it drops, 60, 70 degrees.
Sample one.
Shrimp.
Yeah.
Okay, kind of failed on my gauge. Failed on my gauge recordings.
We got a good 2 in there.
Yeah. We're busy.
So he's holding 30. Before it was like 115, right?
115 max when, I mean, I could
inch down.
do a micro, like half inch or something. That's climbing. Slowly. It might depend how far in I am, like away from the vehicle right now as well. Oh, it's dropping now.
Oh, it's dropping.
You may, I mean, we may want to clear out this black piece that's hanging out in front of us.
You think it's probably like a baffle?
Well, it'd be easy to push the wand up against that, I think, which obviously we don't want to do. Well, now we're at 106.
I think I would want to measure the lower temperatures first till we get to the higher ones, just so in case I do melt it, we still have some samples.
Yeah, I just think like I got to push it in towards that black friable piece to get the hot temperatures, and then I'd be afraid we were going to like suck up stuff into the wand, you know?
Okay. Yeah, we can knock that down. As long as it doesn't collapse that hole, I guess.
Well, that's pretty hard, actually. That's moving the temp probe. I have to do it with the arm.
Okay.
So we'll do a little handoff here.
Okay.
I'm busy.
All right. Bye.
So we're gonna wait for them to shift change. It's 12 something now. Yeah. No, I'm good. It's easier for me to see when I'm standing up.
Hi, team.
Hello. Hi, how's everyone doing? Is everyone on headsets and is the handover complete for everybody?
Yep.
Yeah? Pretty much.
Waiting on video. Waiting on video.
Okay, we're waiting on data loggers back here as well, so
Okay.
we'll give it a couple more minutes. Eric, how are you all set up? Are you... All right, video's on. Sorry, just putting on a sweater. No worries, thank you.
Hardware-wise, we're just gonna figure out what's operationally feasible with Trevor first.
Okay, no problem.
So Josh told you about the knocking that black spire down?
Yeah, so I can stow the temp probe wand and then we can do that.
Sounds good.
Is that time for that now then?
Yeah.
Okay, come wide please, Jess.
You got it.
Yeah, that's the ROV's temp probe. Ours is on the end of that inlet that's still stowed away. And we're probing with that first because we don't want to stick our wand into, you know, anything higher than 120 degrees because we'll start melting, number one, the wand, and if we start pumping, we'll melt the internals of the super
magnets.
sampler.
Eric, sorry, just before we get started as well, obviously whenever you want anything logged, if you can just say everything quite clearly so that Aubrey can get everything into the event log as and when you need it. So we'll just confirm everything that you say to make sure that's exactly what you want entered at the right time.
Okay, sounds good.
Okay, great, thanks.
Hey Eric, is this hard enough that I should pull out the crowbar to poke it with?
I think the black thing is pretty hard. I think Josh was using the arm before to clear the white stuff, but I didn't see him clear black stuff yet.
Okay, I can give it a test poke with the jaws, and then if we need to use the crowbar, I'll pull that out.
Yeah, just try not to like collapse the hole.
Collapse the hole, so I want to push it away from the hole.
Yeah, maybe to the right, if that's possible.
Let's see what I can do here. Cassidy, could I get bubble on the vent, please?
You need a charger? Use this one.
Yeah, good there, thanks. Okay, Jess, zoom in, please. That's good there. All right, let's go for this.
Actually, it's pretty crumbly. Yeah, it looks better.
Is that more what you're looking for? You want me to get that back part out too, over here?
Can't really tell what that is. This looks like discoloring on the back of the wall.
Can you line up the thing again? Yeah, well, I mean, whatever you think's best.
I think that's just a black back wall, right? Can't tell how close it is.
Want another zoom?
Sure.
Let's check out this wall.
I think that's okay. This should give us enough space to work with. Why don't we try using the ROV temp one again? Find out which spots are low temperature enough.
Sounds good. Okay, come wide, please.
What was the max temperature for your wand, Eric?
I'd be comfortable with like 115.
Okay.
But I think I want to take cooler temperatures first, just in case.
Just in case. Yeah. Understood.
Yeah, we're just doing the RV temp probe right now. I haven't started yet.
Why is it so noodly? Let me do that again. Do it again, but better. Eh. There we go.
Video, is it possible to put the sonar out on sat 3, please?
Absolutely.
Thank you very much.
Okay, could you zoom in, please, Jess? Good there?
Is the bubble in a good spot?
Yeah, that's perfect. Thank you. Okay, Eric, wherever you think is best, I'll put it there.
Let's slide it forward a little bit.
Can we also reset max temp?
You betcha.
6, 5. Let's see how high it gets here.
So I'm just barely in the flow.
Slide it in like an inch more.
Hello.
Goodbye. Trevor, do you need bubble?
You can take it.
So we're seeing some decreases in the primary comp. It was 7, now it's 5, now it's around 3. Then again, it hasn't been logged for a little while. Seeing some decreases in the res too.
Okay. No problem. That's like right at launch. That'll come down to this level like immediately.
Okay.
It's about 85 degrees there.
Okay. Do you want bubble in any specific spot?
It's whatever right now.
Okay.
Trevor, could you move it down like 1 inch?
Down 1 inch, aye.
Yeah, that's probably too hot. Move it back up 1 inch.
Up 1 inch.
If this lands back around like 80 degrees, we'll take a sample.
You want to reset the max?
Sure.
Still dropping though, so.
Still baffles me that 1 inch can make such a difference.
Still dropping. Alright, let's swap the wands for the inlet.
Roger, come full wide, please.
You can start to sample once he grabs the inlet, and then we'll know what the background is. If you want.
you zoom in for a sec, please? Am I in the dirt there? Not quite, but nearly. Let me move this guy out of the way. Oop, too much. Okay, come wide.
Video, when you have a moment, can you push bubble back out on sat feed 3, please? Absolutely. Thank you.
So Eric, do you want this vertically on coming in the top, or can I have it horizontally? Do you care?
You can come in from the top or horizontal, but we need to make sure that we don't go too deep, because when they stuck the inlet in there with the IGTs,
yeah,
it got pretty hot pretty quick.
Roger. Well, we'll do it real slow and careful.
Can't hear you. What?
Am I the only one who sees these temps?
You're the only one who sees it.
Actually, change my mind.
I got my this temp here.
Got it.
Can we zoom in on the tip for 1 second?
Sure. Go ahead and zoom. Can we just square it up?
Yeah, is there? Can you point it at some sediment? Just want to see if it's.
Point it at some sediment?
Yeah.
Like.
Make sure we didn't suck any crap up. I want to reverse the flow.
Sorry. Oh, I understand.
Yeah.
Okay. Come wide, please. Full wide.
And can I get the bubble cam on the flow meter?
I'm going to use that for putting it in the vent before we put it on the flow meter. Oh, you want to do the sediment first?
Yeah. I want to just do a check.
Understood. Okay, zoom in on Herc, please.
Yep, that's blowing up the end.
Okay, I'll pull it away.
Awesome.
Okay, full wide.
Alrighty.
So you keep an eye
We're
on this temperature.
very cozy with this
Don't
deck,
go, like,
this vent.
critical.
Can you give me a partial zoom, please? Good there.
So let's start up high.
Yeah, is this too high? Probably.
No, I think that's fine.
Okay.
Safer than sorry.
Better to start too conservative than the alternative.
Yeah. Let's move it in an inch.
1 inch in.
Again, if you guys are getting temperature readings or anything that you want logged, make sure you're voicing that over the system.
Yep, I'm just monitoring it right now. Make sure we don't melt it.
We got a little boost. Yours is still low.
Mine is still low.
Can you hear me through that or no?
No.
Should I put the other headset on?
Which one are you on?
Or am I muted?
No, I can hear you. Just might need to
I can
speak
hear
up
ya.
a bit more. Move the mic a bit closer.
Is that better?
That's better.
Yeah, I
Much
can hear
better.
you now.
Okay, cool.
Thanks, Michelle. That's great.
You're at
All right.
45 degrees and mine's only at 2. That's
Yeah.
weird.
50 degrees.
What temperature are we hoping for?
I'm looking for anything around 50 or higher.
It's
Right now.
fluctuating a lot right now. We're back down to 20.
Yeah, we're probably just at the edge of the flow. Can we move in 1 more inch?
In another inch. I wasn't actually super in. Let me try that again.
It's more down.
Michelle, just to confirm, are you reading the ICL from the IGT
Yes.
temperature probe?
Definitely in the
Yeah,
Yep.
flow
that's
now.
correct. And Eric will have the temperature, the thermocouple from the super. if
Oh
you
wow,
read-
we're high. 138.
Getting out of there. Ah! Bail out.
All right, now we're down to 70, 60,
Yeah,
50.
I'm way out of the flow.
I'm
I just
reading 60 right
stopped the
now.
melting action.
What's the safety limit for this probe?
120.
120?
I mean, it's only if it's
See
sustained in
that.
there for a while will it start.
Yeah, of
melting.
course.
Yeah.
Right now I'm at 42 and that says,
I'm quite far out, so it's probably going to
Yeah.
cool down more.
curious whether it's my probe or not. Because you were reading up to 1 something and I wasn't.
Yeah, it bumped to like 140.
Quite a bump.
I mean, they're, what, a centimeter apart, so they might see
Yeah.
a
Right.
difference in temperature.
What are you reading now? 20?
Yep.
I'm pretty far out of the fluid, so I'm waiting for your go-ahead to go back in.
Yeah, let's move in closer.
Okay.
Stop right there.
I'll stop.
It's pretty in the fluid.
I'm at 48 and growing.
Mine's still at 20.
It might be different response times, too.
Yeah, I think mine.
Mine's kind of fluctuating between 53 and 56.
I'm at 34. Oh, you're recording this, right?
Yeah, it's all being filed.
Can we move in 1 more inch?
Yes.
Right there.
62, 70, 80, 95, 100,
Let's move it up vertically an inch.
down to 87.
$75, 51. Oh, that's kind of weird.
Have you still got quite a big offset between the two temperatures?
Yeah.
Yeah, but when we were with the ROV probe here before, it was actually pretty cool. So it's kind of odd that it's 70 something on the IGT probe.
Do you guys try to co-locate the two probes since yesterday's dive?
They're only a centimeter apart.
So still the same displacement as yesterday?
Well, let's take a sample here. Is it steady or no?
It's fluctuating from like 67 to 75.
Trevor, can you move it in an inch?
1 inch in, and same vertical height.
Yeah.
How's that look?
All right, we're going 95, 109, 117. We might want to pull out.
Pulling
128.
Bring it vertical, actually.
How about that?
We're decreasing 85, 80, 77.
I can go in a little more now that I'm up higher.
Let's see where this stops at.
Hey, Michelle, which headset are you on?
Is this 1 or 3?
3, I think.
Thank you.
This is holding around 70.
3.
Awesome, thanks.
Yeah.
Let's take a sample here. Oh, it's dropping again.
The higher we get away from it,
Yeah, I think it's
the
just
more
going to get
likely.
diffuse all the time, so we'll just mark down a temperature for start. I'm going to start sample now at 1925.10. You mark that down?
Yep, confirm that. Aubrey's logging now.
Can we take a quick look at the bubble cam?
At the flow meter?
Flow meter, I mean, yeah.
Got it.
Just want to confirm it's moving. Yeah, it looks like it's
Yeah,
moving.
it's moving.
Spinning.
Okay.
You want to lock it down here?
Yes, please.
Okay.
And Eric, you're in tube 1, is that correct?
Say it again?
You're in tube 1.
Yeah.
How's your temperature readings? Are they stable or are they fluctuating still?
Fluctuating from around 60 to 70.
And my readings are around 55 to 60 or so.
Okay. Thank you. I'll keep asking occasionally just for a quick update so that we can keep...
What are we calling this
Sure.
site? Waypoint 1 or something? Or
It's actually labeled Candelabra.
Candelabra. Okay.
But it's also near waypoint 1.
Gotcha.
Yeah.
What's our depth?
2732 meters.
Thank you. So I'm aiming for 7 volumes to go through there. So my flow counts I want to be around like 5750. And right now I'm at let me see the flow counts right here.
Yeah. Okay.
Do you guys have a target flow rate and final volume for these samples?
We're looking for around 14 liters. That's 17, sorry, the 7 volumes of water going through the bottles, the tubes. So we have to replace the DI water that's in there right now with vent fluid.
Oh, okay, so the fill with DI water, so the first part is to replace that DI water with
Yep.
the vent fluid and then continually flush it to a point at which you're happy that you've got
to about 14 liters.
14.
You can record the start flow counts at 750.
$750. Start flow count. So you take a start and an end flow count reading, is that correct? And that's what you pump into your Excel spreadsheet to work out the flow count across the deployment? Mm-hmm. Okay. Thank you.
Looks like my temperature probe's pretty stable.
Yeah. It's caught up, kind of. Maybe not.
What are your readings at the moment for the 2 probes, 2 couples?
Mine's at about 70.
Mine's like hovering around 60 plus or minus 3 or 4.
Okay. Thank you. Do you want to continue a continual view from bubble on the paddle wheel, or are you happy?
Oh no, it's okay right now. I just wanted to visually confirm it. I have full counts here.
Okay, so you can see the flow counts coming through, so you're happy with that. Okay. Thank you. So is the idea with the 14 bottles, Eric, or the 14 samples, to get a good gradient to test this adaptive sampling?
Yeah.
So you're just going to go through 14 different temperature ranges, different orientations and all sorts.
And spatial around the vent.
Oh, okay. So even outside of the fluid flow, as it were, like outside of the direct flow of fluid.
Yep.
Perfect. Okay, thanks.
How are we looking on time, Lee?
Started at 1925 UTC.
Oh, I meant like dive-wise.
Oh, dive-wise. Yeah. You take as long as you need. I mean, you have 10 minutes allocated for the filling of each one of these bottles. Obviously, we had a delayed start, so we are behind, but in terms of how we're doing relatively on this time, it's fine. No problem at all.
M&Ms? I'm okay.
You always bring candy in here.
Do you anticipate each one of them being 10 minutes, or is that... Sorry.
I'm not really sure right now. I tested the flow rates on surface, so we'll see.
Okay, so after this first one, you have a better idea of how long it will take to do the 14 litres?
Yep.
Okay, thanks.
Thanks for the chocolate.
It's Candy Watch. So Eric, are you controlling the rate at which this is flowing at what you think the flow rate is, and then you're calculating what the flow rate actually was after the fact?
There's 2 speeds on the pump that we have that's programmed. Slow speed and fast. Slow is like around 1.3 liters or so. And the fast is, I actually haven't clocked that one yet, but it's pretty fast.
So you're
like
on the
probably like about 8
1.3
liters a
slow
minute.
right now?
Yeah, we're on a slow one.
Okay.
Can we get an update on temperatures, please?
We're reading about 70 on the IGT probe and 65 on the super probe.
Great, thank you.
I think what happens is there's like little puffs of fluid that come through really hot, and this response rate might be faster than mine. So mine kind of like almost like mellows it out a bit, whereas this one's just like reading every high, low, high, low, high, low.
Yeah. Is your probe the one that's a centimeter higher?
Well, it's actually lower because it's
okay.
upside down compared to where it is. I think that it's along the shaft of that intake wand, that metal part.
Yeah.
It's hose clamped to that.
Okay.
They're really not that far apart.
Yeah,
But
now they're much closer than
like mine's in plastic and his is in metal though, so.
Is your thermocouple actually embedded in the plastic, and is it just the tip that's exposed? How does that?
It's an RTD sensor, so it's like right at the end of the wire.
Oh, okay.
I think it's similar to Sean's, but his is encased in metal.
Oh, I see. I understand.
Yeah, mine I built into the intake probe.
Eric, when you have a moment, could you possibly explain what that's made from? I believe that you 3D printed that?
Is someone talking to me?
Yes, Susan. I was wondering if, when there's a break, if you can explain how you 3D printed that, the materials that you used.
Sure. In a minute, though.
Mm-hmm.